Map properties. All maps distort the Earth's representation. They do not all show areas of the world in exactly the same way. This occurs because of the difficulty of showing the Earth's spherical surface on a flat map. Cartographers can take the information from a globe and flatten the surface of the Earth. They use different map projections, ways of showing the round Earth on a flat surface. However, size, shape and distance are distorted when curves become straight lines. There are four basic aspects of the Earth that can be distorted on maps. Map makers choose which projection to use depending on which of these map properties are the most important to the area being shown. No world map can have all four of these properties undistorted. Most maps show the properties accurately but distort the others. Smaller maps usually have less distortion than larger maps. Distortion is generally less on all maps near the center of the map and greatest at its edges. Different map projections are developed for different purposes. These days, many types of maps can be prepared through digital computers, as they have all kinds of processing software, specially designed for map making. Correct shape. Maps that do not distort shape are called conformal maps. Shapes of land areas conform to or look like the shapes on a globe. Straight parallels and meridians cross at right angles, and most often used for world map. Example, Mercator spreads the images near the poles, distance and size greatly distorted at polar regions. Shape and direction are accurate and valuable for sea travel and ship navigators. Interrupted. World looks broken apart. Direction and size are distorted. Shape is accurate, valuable for showing land masses and data. Correct size. Maps that do not distort size are called equal area maps, which show relative sizes correctly. These are in distorting shapes, good for data representation. Correct distance. Maps that show correct distance are called equidistant maps. It can never be a world map, and small areas have little distortion of distance. Correct direction. Maps that show true compass direction are azimuthal maps, which show the Earth centered in such a way that a straight line from the center to any other point represents the shortest distance. It can only show half the Earth at a time, which are circular in shape. Directions and distances are accurate. When the line of travel passes through the pole, directions cannot be shown on a compass rose, valuable for polar, air and oceanic navigation. Example, polar maps. North or south pole in center of map and is used in air navigation. Compromise projection have none of these properties and therefore distort all four of these aspects of the Earth. However, they try to lessen overall distortion and are good for data representation. Example, Robinson projection. This has minor but not major distortions. These are equal areas. Relative size shown with high degree of accuracy. Shapes are accurate except at edges where distortion increases. Valuable for showing entire world. Good to show data and often used for maps in educational materials.